Welcome to the new episode of Blockchain of the Month podcast. Let's continue exploring Manta Network. This will be our last episode in the Manta Network series. So if you have not checked out our previous videos, kindly check it out. The link is in the description. So the last two videos we have saw how to deploy a smart contract using both hard hat and remix. So in this video, let's see the specialty of Manta, that is ZK based application. Let's explore the ZK ecosystem in Manta network. As I mentioned in the previous videos before, universal circuits are the packages which helps us to deploy ZK based applications easily. So one such package is ZK Shuffle. So what is ZK Shuffle? So before knowing what is ZK Shuffle, let us find out what is the problem that ZK Shuffle solves. Consider a game of poker being played between two or more players. There will always be a mediator between them to shuffle the cards to all the players. In poker terms, the mediator is called a dealer. So how will we know the mediator or the dealer is conducting the game fairly? Do we have any proof for it? What if any player bribes the dealer to favor them? So to avoid this, we can use zero knowledge proof and ZK Shuffle package. So what this ZK Shuffle package does is, so ZK Shuffle package provides a zero knowledge based proof that the cards are shuffled randomly and no player has influenced the dealer. So this is where ZK Shuffle is used here. This ZK Shuffle package contains four main components: circuits, contracts, SDK and game contract. So let's take a detailed look about what these each four components are. Circuits. Circuits contain the code for implementing encryption and decryption using zero knowledge proof. It is written using a language called CIRCOM, a language specifically used for writing ZK zero knowledge circuits. Contracts. This component contains all the contracts that needs to be deployed to the network. The shuffle manager.sol contract manages all the shuffle cards and their proof. This contract serves as the entry point to the game. So this, when players want to join a game or they want to create their own game, they have to interact with this contract. Game contract. This component is also similar to the previous component, but the previous component just serves as an entry point to the game. But in this contract only, we'll define what are the logic behind the game based on the number of players that are playing the game and number of cards used. So now let's just define a simple game. Here we are not going to use the poker to explain this. So let's explain this game with a simple example. These are the rules of the game. So consider two players playing the game and the dealer will shuffle the cards and give them, and whoever gets the higher value will be the winner. So just first let's list out the step-by-step process of the game. So first these two players will register to the game, and next the dealer will start shuffling the cards and hand over each one to both the players, and next, seeing these cards, the players bet based in off-chain. So the betting process will be happening off-chain, and after betting, now they will reveal the cards and whoever gets the higher value will be the winner. So this is a simple example of the contract that we are going to see. TypeScript SDK. So this is also a component which the package offers. So this component will offer a front-end code interface through which we can integrate with our project. These are the four main components that are used in this package. So by using this package, there is already an application which is built using this package on top of Manta Pacific mainnet. So ZK Hold'em is the name of that application that is used. So you can also check out ZK Hold'em, but you need mainnet funds to use that. So that application is built using this ZK Shuffle package. These are the four main components used in the package. Now let's see how to use this package in our project. So now to use the package in your local project, we have to download the package from the GitHub repo. So this is the GitHub repo from they have to download. I have given the link in the description. So just to clone it, so go to the terminal and click git clone. clone the repo. So after cloning, move into the repo. Now let's install all the packages using yarn. So here it is using yarn to install all the packages. So if you not have installed yarn, follow this commands. I have already installed yarn, so I have just using yarn command here as it will install all the dependencies. So now all the dependencies have been installed. Now let's compile this package. So to compile, follow this command yarn workspace for each run compile. So now it has actually compiled. Now let's test out this package. So to test out, go to the packages, and inside that there will be a contracts folder. Go to contracts, and here there will be test folder. I'm not going to test all the test cases. I'm going to test only one simple test case. So let me go to Visual Studio Code and just comment out the rest of it. So here there are different test cases here. So here in this case it's for 5, 30 and 52. I'm going to use only the 5 cards test case. So just mention yarn test. So here you can see the starting. So as we mentioned earlier, so this person is creating the game, and this person has joined the game and assigned as player ID 0, and now is this turn, and this player's turn 0xF3 9 of turn, and he is assigned a player ID 1. So now let's wait for the cards to be shuffled and handed over to player 0 and player 1. So this is the game ID which we given here. So player 0 card has been shuffled within this time, and now the player 1's card has been shuffling. So player 1's is been shuffled completely. Now we are going to reveal what card they have. So now it's decrypting them. So first we are revealing player 1's card. So within this time the betting will happen off chain. Whether the player 0 has betted that my card will be higher, or player 1 has betted his card will be higher. For instance, let's say player 1 card. So I am betting that player 1 card is high. Let's see the result. So now player 0 is opening. So player 0 card is 3. So player 0 card is 3. So let's check what is player 1's card, whether it's higher or lower than 3. So in this case there are totally only 5 cards. So that's why it is within these numbers. So player 0 open chain card also is 3. So player 1 card is 2. Off chain card is 2. So that means player 0 has won the game. Player 1 has lost the game. So by this way we can say that it is completely decentralized and not in any dealer or mediator control. So let's wait till player 1's on-chain proof has been submitted. So that it's ended. So this is the game of Elo end-to-end 5 card. So this is how we can use this package to deploy, to interact with our own local project. So with this we conclude the Manta series, and in my opinion Manta is still growing and it will continue to grow. So there are still more exciting times ahead for us. So see you then. So this is Vishwa dispersing. Thank you for listening to this video.